Hey friends and everyone, welcome back to Netcode-Hub channel. My name is Frederick and I'm happy to have you here today. In this video, we are going to look at how to create robust and resilient web API. As usual, if you haven't subscribed to this channel, please do not forget. And also click on that bell to receive an update as soon as I do upload new video. The bell is found in this video. I hope you've seen that. Good. Alright, I do also offer coaching sessions to people who want to improve in their .NET skills, talking about Blazor Web API Service, Mari, and etc. So if you're interested, check the video description. I have an email in there. You can write to me through it. Okay. When we say robust and a resilient web API, what actually is it? It is any API at all which is designed to be strong and reliable even when facing challenges. Let's break this down for you to get the better understanding, the basic one, okay? Let's first take the first keyword, robust. Robust web API must be stable, meaning it should handle different types of input and a request without crashing. It must be error resistant, meaning it can manage unexpected error and provide useful error messages. It should be consistent, meaning it should behave the same way under different conditions by ensuring predictable performances. Good. So with these three key features here, if any API is having these features, we can classify that API as robust. Alright, this is clear, isn't it? Good. Let's go to the resilient. Resilient web API, what should it do? It should be fault tolerant. So it should continue to work even if some part of the system fail. It should be recoverable, meaning it can quickly recover from issues like temporary server outages. And the last one, it should be adaptive. So this means that the API should adjust to changing conditions such as varying loads of traffic. So if an API is able to possess these features at all, then we can classify that API as resilient. So now we spoke about at least 6 features that an API needs to possess to become robust and resilient. And in this video, there are a lot of features. We're going to look at some of them. I have already made a video on how to implement retry, wait and retry forever. Okay, these endpoints. Now these are coming from an old version of a poly. That is a version 7, but it still works. Okay, so if you want to use that, yes, you can go ahead and use that. But I know there are different things. There's a new package that is a poly.core, and this package encapsulates some of the functions or the APIs in this poly, and I'm making it very simple and easy to use. I'll take you through that. Okay. Now there are 2 packages. Maybe if you know poly, and now there's a new package known as an extension of what poly, and that is a poly.core. So with these 2 packages, which one should you use? Which one do you need to choose when creating projects and want to implement some features such as circuit breaker, retry, raise limit, hedging, timeout, fallback, and etc. So I'll take you through for you to make a choice on which of these packages that you need to use. First of all, let me show you. Now let's try to install this package first, then I'll show you the 2 types that I'm talking about. So make sure you have your project created. Like you see, I have a project created, what is it created? So that's a solution created. And I have added 2 projects, that is the 2 web APIs. I named them API 1, API 2. So let's see. Now we're going to install this poly package to API 1. Let me show you something in here. Right click on dependencies and I go to manage NuGet packages. And now in there, make sure you type in poly, P-O-L-L-Y, poly. Type in that and check it out. The 2 types I'm talking about. So poly. Great. Do you have this? Now you can see we have this. What I want to emphasize on, not what you see in here. Not this one. I want to emphasize on poly.core. Do you have poly.core? And poly itself. Okay, so I'm not seeing the main poly. I'm seeing poly.testing. Let me make it. Actually, let me do it well. So, poly. Okay. So you can see we have this poly. And now this point, the current version here is an 8.4. As you can see from here, I have this poly package installed. And now we have an extension. We also have poly.core. So this poly.core and this poly, actually, they have the same endpoint. But the question is, why do they have these two polys? Okay, so check this. Now this poly here, I think it was, that is the date published. That is the 2024 May 10th. That's an update of the 8.4 from the version 7. Now when you go to the poly.core, it was updated or published where May 10th, the same day. So why do you have two packages? And now actually when you look at this, it has the same thing. So exception handling, resilient, transient, fault policy, circuit breaker. Now when you check this one too, it has the same thing. Okay, so let me take few seconds or a minute and I'll take it through the reason why we have these two. And now, which one to choose based on your project that you're doing or you're continuing. So first of all, let's talk about this poly. That is the main poly. Now this poly here, it is the legacy package that exposes the API used in the version of the poly prior to version 8. Now you know this is version 8, this is the current version. Now in version 7, that is why I've made one video using wait and retry async, wait and retry async, retry forever, wait and retry forever. So these are the endpoints in that version. The previous one, that's the version 7 and below. And now it has been updated. So this is the original one, or this is the original one. That is the old one, which has been updated, and that's what currently we have. So all the current endpoint that I'm going to talk about here, poly package also has this endpoint. Okay, it has this endpoint. So now let's go to the poly.core. Then if this has the current updates and it has the previous one, then why do we have to get this? Now this poly.core package contains the core abstraction and our built-in strategies. It is the foundation for resilient policies and provide the essential building block for handling transient fault in your application. So this contains only the code made for version 8. But with this, I think you can have access to the version 7 and below. I hope this is clear. Now, if you are creating an application, which one do you think is suitable? Or which one should you use? I hope that's the next question, isn't it? Good. But if I ask you which one will you go in for? Now, the point here is, if you have started with Poly already, then continue with that. Because all the feature that it has in the Poly.core, Poly also has it. But if you are now creating a new web API, then, my friend, make sure you choose Poly.core. Okay, so that is it. So in this video, I'm going to install Poly.core also. I'm going to have the two packages. So I have Poly and I have Poly.core. Maybe I can remove the Poly in here because I want to emphasize on this Poly.core. So let's install this package to it and boom, we have it installed. Okay. Alright, so in this video, by using this Poly.core, it gives us an access to circuit breaker, fallback, hedging, rate limiter, retry, and timeout. Okay, there are a lot, but I'm going to talk about these 6 or 7. 6. But as you know, in the overview of a resilient and a robust API, we made mention of if an API can be resilient and robust, it should handle issues, exceptions. So in that, I've already made a video on how to handle exceptions globally. I spoke about locally handling exceptions and now globally handling what an exception. In locally, you can use try-catch block to handle exception to a specific statement that you want to try. Aside from that, if you want to handle it globally, then we can implement the interface of our exception handler, or you can use the middleware to handle that. And in that, I made a video explaining the two, handling it locally and now globally using the exception interface and also using the middleware. So if you haven't checked that video out, please I'll put it in the video description so that you can check it out. Okay, I don't want to go back again, so we can shorten this video. That sounds good, isn't it? Great. Okay, but I have the implementation here. So it's the same video, the same project that I'm continuing with. So I have the custom exception and all this. I made the explanation to this. So maybe please do check the video description for that. If you don't know how to handle it globally or locally, you can do that. All right, now let's see. So now that we have these two packages installed, what I'm going to do here is I'll go to the packages in here from the dependencies and our packages, and I have Poly and our Poly.core. Since I am emphasizing on Poly.core for the new abstraction, I want to remove this Poly which contains the old one. Maybe I'll have some time to go through the old one as well when I have time. But well, when you install these two packages, you can use the same thing together. It's the same. Okay, so let me remove one and I maintain this poly.core. So you know, in the poly, the current, that's the 8.0, 8.4. Now instead of you to use, or when you want to use the retry, in the old one version 7, you have endpoints such as wait and retry, retry forever, retry async, retry, wait and retry async, a lot. Okay, now all these, the abstraction here, it has been, the polypack team has made it one, so we can now add poly in the version 8. Now in order to add version 8, you can first put it in the program.ts file. You can register it as a service, so you can be using that, or you can also use it based on the file. So you create an instance and I start using that. Now in order to use that, you have to first create an options. You can decide to specify these options in the pipeline, or you can create an options in that and now call this option in the pipeline. Well, talking is too much, isn't it? Are you confused? Don't be, because it's very simple. Now let's go through and now let's see. So first of all, let's have a look on retry. So what is the purpose of retry policy? The purpose here is a retry fail operation and for a specific number of time before ultimately failing. So you know, when a user executes a request, and if the server which is going to respond to the request fails, we don't want to return the response once the server fails. We want to retry again, maybe based on the specific number that you're going to specify. You want 3, 4, 5, 6. Then within our request, if it still fails, then we can tell the server that hello. We can tell the client that hello, yeah, the server failed. Or you can handle that exception using the global exception or the interface, exception interface, to handle that, and I display a certain message to the user. Okay, so that's the purpose of having this retry policy in the poly. Let's see how to implement that. So as I said earlier on, we're going to make our API 2 as an external service. Although we have it over here, but think of something in the air, okay? Something that you're going to have access to. It is somewhere else that we're going to have access to, although it is close to us. Does this make sense? Yes. Okay. So let's say now in our API 1, you can see we have a default controller, and at this default controller, in the previous video, I made mention of I did this, all this. I did this, all this. Yes. Yes. I did this, all this. I did all this. I'm going to clear all this. That is using the version 7, and here we're going to use a retry async and a retry and wait, retry forever async. That is a version 7.0, and now I'm going to cover that anymore. And I want to cover the new one. So maybe I would have to get rid of this. Yes. Okay. So this is what we have. You see, I am injecting an HTTP client into our constructor, and now using this primary constructor, I mean you're going to make this instance available from the scope. No, from the scope or to the scope. Yes, within this scope. So it can be used anywhere. That is a C# version 12 and introduction of what primary constructor. All right. Now, once we have this in here, let me remove this from the top here, because they are not of no use. Good. Now there's an endpoint 7001. There's an endpoint to the second API, and in here we have there's a method called what? Connect, which is returning an HTTP response message. Okay. So here we have get, and this is going to return an enumerable of weather forecast. So we're going to make a call to this endpoint in as a service sitting somewhere else, and now when we get a response, we're going to return it in here. But we're going to make this request server failed. We're not going to start the server, so that we're going to have no machine, or the machine refused because it is not actually live. Now in that, we need to retry the server times based on the specific number that we're going to specify before we finally or ultimately what? Failed. Now let's try that and see. So once we have the package installed, so first of all, let's create a retry strategy. I said earlier on that if you want to use any endpoint in here or any strategy, you have to create the option. Aside from creating the option, then you can use this option in the pipeline. So there are two things: create an option or use the option in the pipeline, or you can specify the option when creating the pipeline. Okay, so it is two. I want to separate each so that maybe it will become clear to you than specifying it at once. Well, it's a choice, so choose a choice. It is my choice, choose yours. Alright, so first of all, we're going to create this strategy, and now in that, let me just uncomment this. So you can see that here, we are creating a retry strategy, and now this, we need to use this poly.core. That's a retry. So when you have a look here, you see we are creating this strategy, and now we need retry strategy options, and this is coming from the poly.core package that we installed, and a section, a class known as what, the retry. Good, that's the namespace. And now in here we are specifying using poly delay backoff type as an exponential. So when increasing, do you want to make it as constant figure or do you want to make it as an exponential? Yes, so we're going to use the math.power. Yes, and you're not doing math here. Let's continue. Okay, so this is going to add a random factors to the delay. That's the use jitter. And now maximum retry attempt. So these are the things that matter most. Maximum retry attempt. So here I want to retry 4 times, okay, before we delay, or we can, no, before we return to the user, or we can retry maybe 6 times, 5 times in here. Now delay for 4 seconds each. So if I make a first request and now it dies up, it couldn't connect, then I'll wait 4 seconds, I'll make another request. So I'm going to retry for every 4 seconds here before to check if the server is alive. Now on retrying, I want to display this to the console. Okay, so this can be, you can call any method at all, but here we are calling something to the console so we can read what is going on. I hope this sounds great. Good, after doing that, do you know what the next thing to do? We are going to create our resilient pipeline and now build it and now add our retry strategy. So the strategy that we have created in here, we need to create a pipeline. And now we add our, so let me comment this. Yes. So you can see from here that we add this retry. So resilient pipeline, this is a pipeline. Maybe I can make this as retry pipeline. Yeah, this retry pipeline. And now we add this strategy in here into the pipeline point that we call in here. And now we're going to build that. So after I build that, this pipeline is now ready for execution. How do you execute? How do you execute? This is very simple. So in order to execute, we can just have something very simple like this. Let's see. Now I know that we have this connect API, and that is going to return HTTP response, isn't it? So maybe we can, this is unused, so we're going to use it now. Now let me uncomment this. Okay, so we have copied this retry pipeline, and I'm going to replace it down here. Now within this, we are calling a response.await. Now this is going to call, so instead of this, we're going to replace it with this one because this is, we are using the method down here. Okay, so we call this is going to return what, HTTP response, and now we can check if it is success. Then we want to convert it into what, a list of this, visualize it, and now if it is not, we're going to throw an exception. Okay, so if it isn't, we're going to throw an exception. And now with this exception, you know, from this, we are going to handle this. And now defaultly, there's another endpoint that we did not configure, and that is should handle. Now should handle here, that's where you need to specify the exception that you want. Defaultly, this is specified to any exception aside from cancellation or cancellation exception. So defaultly, that is what has been configured on. That's the reason why I am not configuring this should handle. Okay, but we can still override it. In case we want to do that, we can override this exception, this should handle property in here. So in order to handle this, we have to specify with this as new predicate, and our predicate builder, this. And now in here, we are going to specify .handle. So which exception? And now you want to handle all exceptions. So maybe you can make it specific to this, but we want to handle all exceptions in here. Okay. So any exception at all that's going to be raised up when this method is being called up, that is where you're going to execute this. Okay. All right. So now that we have this, what else can we do? We can now go ahead and now run it. Now you can see if in case everything is all right, then here we are returning result. Now the result that we are returning in here, you can see we are using this lambda expression. So the endpoint, the end here is going to be result of this. Now when you have this result, that's going to be what? That's a list of weather forecast. And in there, we want to return this weather forecast. Okay, so that is exactly what you want to do. Now let's try this. We make sure we have our console running up, and now let's check it out. So I believe you can now see the screen. So we have the Swagger open down here. This is on our left. Then we have this on our right. This is the console, and now we're going to click on this. You know, we haven't started there. We are starting only the API version 1. That's the API 1. API 2 is offline. So definitely, when you try to make a request, it won't reach the server. Okay, so in this, you're going to try an exception. And in that, we are handling this exception, and we're also calling a retry again based on the exception that we have. Now, see, click this, and now execute this. Now let's check it out. So you can see it is sending a request to this 7001 endpoint to the controller this, and I couldn't. It failed. So you can see I'm having a retry. So this is the first attempt. So attempt here after making a request. This is the first attempt. It is still not sending. It couldn't. Second one is still, you see, so waiting, attempting one. So we have 2 attempts. This is the third attempt that is making, and we specified around, I think, 4 retries. So let's check it out. So there's 1, 2, 3. Maybe we have last one. Then we have the 4th type. And in case this fails, then we're going to return, okay, to the user. So we see that the user clicked on once, but since the server failed, we are retrying how many times? 4 times. Oh, okay, so it is not more 4 times, it's 5 times. That's correct one. Yes. I don't want to deceive you. It is 5 times. Okay. So now when it got to the 4th one, you can see from 0 to 4, that is 5. When you go to the 4th one, you have an exception in here. And if I open this, let's see, you can see that we have this. No connection could be made because the target machine actually fits it. So this is the error that we are having from here. Okay, so this is an error that we are getting. Great. And now in this case, instead of us to display this to the screen, no connection could be made because the target machine refuses it. Instead of displaying this raw exception here, to make your API robust and resilient, you must have a way to handle what? Exceptions. That's the first one. So we are handling this exception, and that is what we did in here. So you can see from here, we are handling an exception from the application exception handler that we created or we went through that time. I made this a video, okay? So you can just have a look on that. And now within that, we are having this at the output. So check it out. You can see instead of displaying this, we have a custom message, internal server error from the exception handler. So I decided to add the exception itself, so you can see that, yeah, that's an exception, that's a real exception. So instead of displaying this, we are displaying this custom message to the user. So the user might not know that it is the server is off. What maybe you can display here, maybe sorry, server temporary down, or sorry, wait for some time and try again. A lot, okay? You can do that. We have a default status code of 500 as we specified in there. Good. So now we are done with the retry. Now let's go to the next endpoint or the next feature that we're going to talk about, and that will be timeout. So what is the purpose of implementing timeout in your API course or in your service course? The purpose here is to set time limit for an operation to complete and cancel it if it takes longer than what's expected. So here you can avoid waiting indefinitely for an operation that may hang or take too long. So in case it takes too long, then cancel that request and you go your way. Very simple one, okay? So in that too, let's see how to handle that as well. We go back to our same end controller in here, weather forecast, and now within this, I think I have to comment this. Or yes. So in timeout, we are going to be using cancellation token. So we have to pass the cancellation token to a method that's going to make a call to the API. And this is very important. And this cancellation token will make sure that it gets the request cancelled when the time overlaps or it delays for too long. Okay. So here we cannot use this method. So we have to create another one. So I'm going to create this connect to API 2. And then that I'm going to specify, I'm going to pass in maybe cancellation token to this. So maybe I can do that like this. So here we are returning a list of weather forecasts. We can also return the same HTTP response. And now that's in the connect to API 2. And here I am specifying cancellation token to this. In that, I don't want to delay this, so that's the reason I commented. And now we're making a call. We're passing the cancellation token. For now, that's the default one. Default one is none. And now if it is success, we want to return the list. In case it isn't, we want to return default. That's going to be empty. Okay. Or we can still implement this HTTP response. We want to be dynamic here so that you know that, yes, we have a lot of ways to implement this, okay? I believe you like that. Yes, I know you will. Definitely. Okay, so now that we have in this, what's the next thing to do? I'm going to make another endpoint for this, and we're going to also make a same call. So let me grab this from here. Let me comment this. And I'm going to say this is, okay, so maybe let me give this a new name. And let's say this is retry. Now this is going to be timeout. That's timeout. So timeout. Now this gonna be retry. Alright, that's fine. So from here we have to implement this ourselves. So let's create our timeout strategy. So I'm going to say that this is timeout strategy is equal to new timeout strategy options. And in that, I'm going to specify this. So the timeout here is what? From 1 second. So if it delays, maybe let's make it 2 seconds. Okay? If it delays for 2 seconds, then you want to set a timeout. And now when it's timing out, when it exceeds, we want to write something to the console. So exceeding time out after the total seconds, what? Total seconds in here. So time is out. You want to just display something like the time is out. So once we have this timeout, the next thing we're going to do here is we have to create our resilient pipeline and implement this timeout. You can see it's very simple, isn't it? Creating timeout is very, very simple. Now, with this, let's see how to work with that. So down here, let's create our pipeline, timeout strategy pipeline. So this is our pipeline. And now in that, we're going to get it from this. So we can grab this one. Maybe let's remove this. Since we're not having a separate class, then we pass in our timeout build up here, and I will build this. So once you build it, then this timeout becomes ready for us. So let me make it as timeout pipeline. Good. Now let's use this pipeline to execute our request. And in that, we're going to specify as a token in down here from this async. And now we're going to specify that token here. Since this method needs a token for cancellation, we have to pass it on down here. Return result, because this is returning a list of other forecasts. So we need not to check the state again. First we are checking the state from here, the first one, checking the state from this retry. By timeout, we are not checking the state. Yeah, returning straight away because we checked the state already. So be dynamic. We don't want to be focused on one side. Okay. All right, now that's good. So let's see. Now let's run this and also check this out. Yeah, so our endpoint is also ready, and that's a timeout. Let's make sure console is visible for you to see what that we're going to have. Let me increase the size here. That's great. Now, if I click on this execute timeout, check up here, we're going to have two responses. One from the UI, which is inheriting from, or which is coming from the exception handler. So hit on the button. Yes. Now let's wait and see what will happen in here. Okay, yes. So we run to an error. First of all, let's check up and see what is an actual error that we are having. So if I go up again, up, yes. Check it out. This is a poly timeout. So this is an exception. Timeout rejected exception. So this is exception called as soon as the timeout that we specified executed. So the operation didn't complete within the allowed timeout of what? This is a timeout that you're supposed to use to execute complete, but I couldn't. Within that, a task was cancelled. You see this? Good. Now, from this, we are not displaying this to the user. So we are displaying it from the custom exception. Whoa. Custom exception, internal server error from our exception handler. But we have the actual exception in here. The time did not complete in here. So once you have the time in here, you can now format it to suit the user's choice. What is that you want to display to the user? You can do that specifically with the exception interface. Alright, so your timeout is also working. Now you cannot make a request and the request won't last 5 seconds, 10 seconds, 15 seconds whilst you still sit. You still sit and stay. Okay, yeah, and wait for the request. So you sit up, when the time is up, the operation gets cancelled and now you can make another request. Okay, so let's say, so maybe if you want to also retry after the operation has been cancelled, then this is coming out exposing a cancellation, maybe exception, or that is a timeout exception. So you can make an retry to handle a specific exception, that is timeout exception. As soon as this exception gets erased, then it can also retry again. So it will be back and forth, back and forth. The retry will try. When it gets to the cancellation token, that's the timeout, it will cut it down in case it couldn't get the response based on the number specified. Then it can retry again and so forth. It depends on how you want to do yours, but there is a way, so you can manage it yourself. Okay. All right, so let's go to the next point, which is fallback. So what is fallback policy? Now, the purpose of fallback policy is to provide a fallback action if the primary action fails. So it ensures that the application can provide a default, at least default response, or handle errors gracefully when an operation fails. So let's say you want to return a list of maybe weather forecast, okay, from an endpoint or from a service. Now, when you make a request, it failed. You don't want to return the request or the failed message. You want to just return the default. Now, default is an instance of this list of weather forecast with no value. You want to return that to the user. And in this case, you have to use a fallback. So if you are planning that you want to return something when something happens or when an exception happens, then you can use a fallback. Now let's see how to also implement the fallback. So I have to close this up. Let me close the console also. And I have to make another endpoint and I name it as fallback. So let me grab this from here. Let me minimize this. So I'm going to make this as fallback. And that is a fallback in here. And then the same thing applies to the name. So default, you know the return type of this method is returning a list of weather forecasts. So first, let's create our strategy. That's a fallback strategy option. So let's first see. We have our fallback strategy. And now here we're going to say that it's equal to new fallback strategy option. And now with this strategy option, we need to specify the return type that we want. So that's a list of weather forecasts. You know this is what you want to return, right? So list of weather forecast. Oh, see what I've done. Okay, so let me remove this. So list of weather forecast. And now in that, we need to specify the following options. So when you have a look in here, you can see we have should handle. So it should handle what? That is when we get a list of weather forecast. Now this is the predicate, and here we also specify the list of weather forecast. This is the return type, and that's what we have it down here. No, up here. There's an exception in case you have any exception. This it encapsulates all exceptions except cancellation exception. Okay, then we want to handle this result. So if the result is null, then there's a fallback. Here we want to get a default weather forecast, and that's we create an instance of this list, and now we want to return as an outcome.fromResult as value tags. We pass in the instance in here. When it falls, you want to write this to the console, and I return default. This is a very simple thing that you want to do. So anytime that there's an exception here, you want to return a list of this. Instead of displaying an error, no, we want to return a list of this. So the errors are going to be hidden. That sounds great, isn't it? Now let's see. So once you have this, it seems like we need to clear this. Yes. Okay. So now that we have this, we have the strategy. Let's go ahead and use this strategy to make an execution. So we can have our pipeline instance created beautifully here. So maybe let me push this because this part. Okay, so we have a pipeline, and this is going to be fallback pipeline. And then here we could see we also specify the return type. And now in that we have our strategy copied. We can place it down here. We build that. Making a request from our fallback pipeline. Then we're going to make a request. Now this request, we don't need any token. Okay, so it is only the timeout. That's why we need cancellation token. But with this, we don't need that. So we can just return, get it straight ahead here, and I return data to as an OK type. Okay. So this is returning this return HTTP response. So we don't need that. So we have to return maybe a list of this. So well, we can pass in still cancellation token, which will still be okay because this is return a list. So maybe we can grab this. Let's make this, copy this token in here, and now pass the token in there. Very simple one. Now let's run this too and check it out. So on the go, we have it ready for back. Let's try this out, execute this. Now you're going to have an issue here because the server is down. But let's see, you can see fallback returned, right? So you can see there's a message, fallback returned. And now when you check it, instead of displaying this error, we have an instance of this. So instead of our errors, where are they? They are hidden, they are gone. We have the instance that we created. So you can pass on default data that you want. You can pass it on that, okay? And you can go ahead with this, okay? So maybe let's try one, passing in the data as an instance of this. So once you get this from our fallback, you can create from here. We can say that this list default weather dot add. Now here adding new. So adding new weather forecast. And now with this date, you can specify date as datetime dot UTC now. UTC now dot date. Would that be okay for this? This date here, it is date only. So do you have dates only? So dot from dates, from days. Okay. And aside from that, we can have our summary. Maybe this is it windy? Yes, that is windy, right? Now the last one that you can temperature here is, let's say 34. Great. Then we can now close it. So you can see that we are creating a new instance of this, and aside from that, we are adding it to this default list that we have created. Okay, so maybe we can set up to this new one. Well, this can work, or we can also use simplified one like this. This is also going to work. Pass it on in here, and now let's give it a try and check it out. So let's see the default fallback. Anytime that we have an issue, we want to get this as a fallback. Exactly. Okay, so that's a way to also handle the fallback. Now let's see the next one. And that will be circuit breaker. Circuit breaker. What actually is circuit breaker? The purpose of circuit breaker here is to break the circuit for a specific time after specified number of consecutive failures, stopping further attempt and protecting the system from overload. Service here, it is down. Now all services are going to make requests to this. In this case, we want to break this service down. We want to open circuit. Okay, so this looks like a bulb in our room. We have a switch. Now as soon as you shut it on, the circuit is closed because it is connected together. As soon as you off it, the circuit or the connection is broken. You have a space in there. The same thing applies to this. When the circuit is opened, it means there's no connection, so you cannot pass a request to the server or the service for a processing unless the circuit is closed. So in that, you have circuit open, we have on reset, meaning when it is closing, and after closing we have on half reset or so. Yes, okay. Now on the half, meaning it's going to check, it's going to set up a trial. Okay, so this trial here, that is on half open. It means it is open, but it is not completely open. It's going to make a first request to see if the server has recovered. If it hasn't, then it's going to still open the circuit again. For all incoming requests are going to be blocked. But in case it makes the first trial and it goes through, then all the other service or other requests coming in can now go to the service and return or receive or get their responses. Okay, so that's the usefulness of this circuit breaker, and it's very important. Okay, to ease the stress from a server or a service when there's an issue that a service cannot respond anymore. Now let's see how to also implement this circuit breaker. So as usual, I have to make a copy of this, and now down here maybe I can just pass in circuit breaker. So the first thing that we need to do here is to do what? I hope you remember. You know what to do, isn't it? You need to create a circuit breaker strategy. So let's say this is var circuit breaker strategy. From here, so it's equal to new circuit breaker strategy, and we can find that in here, strategy options. Okay, now here we can specify the options that we need from here. Now we have failure ratio, that is 0.5, which is about 50% or 10% of the state. We have sampling duration, and that is the 30 seconds in here. Minimum throughput, and that is the number of time that you want to check. You want to allow requests to come in before it breaks up. Okay, before it opens the circuit. So try the first 3 requests. If they all fail, please do open circuit. Now, when you open circuit, how much time do you want to the open circuit to last for? 30 seconds. That is over here. Within that 30 seconds, no request will pass through. It is blocked. Now, which exception should it handle and open the circuit? That is all exception. So here we can make a specific, maybe when you have server 500, that's the internal server exception. When you have maybe timeout rejection exception, a lot. Okay, so you can specify exception here. But here for the general one, we are generalizing it to all exceptions. And if the circuit is open, that is, if it is open and it is not allowing any connection, we can say that circuit is open for this number of seconds. So that's a break duration second, that is 30 seconds. And if it is unclosed, if it is closed, meaning circuit is now closed, now new call can be made. Now for the testing purpose, this is done by the circuit itself. It is half open. We are saying that it is half open. And now the next call is a trial. So it's going to check if it goes through and it works, then all other requests which are going to come in on forth are going to be just processed straight to the service for processing. And that's great. So that's now that we have our strategy created, what we're going to do here is to build a pipeline and now start making a call. So in here we can specify down this, because this is the strategy. And down the strategy, we can create our instance in here as a circuit breaker strategy option. And within that, we need not to, because this we have it already, so we can clear that. So instead of having this, okay, we are also having a retry in here. Okay, so we are also having a retry. So maybe I can get this retry. So maybe you can create an instance of this, or you can create a private which is going to return a retry. Or within this, for us to make another retry, I want us to copy this retry strategy, grab that, and I implement it in the circuit in here. The reason is we're going to make a first call. Now, when we make a first call, when it fails, we're going to retry. Okay, and here in the retry, we are making an attempt of 5 retry attempts, so 5. And now, when here we also going to specify with the circuit breaker, we're going to specify the number of attempts as a throughput, and we said that what we need 3. So we're going to retry 5 times. When you get to the 3rd time, that's where this error is going to, the circuit breaker is going to happen. So it's going to break the circuit. Now let's say, now there will be no more call again. So when you make this as even 8 or 9, when you get to the first 3, the subsequent 5 will be executed with no usefulness. So it will make a direct call, okay? Or it will be called, but it won't get to the service that we want. And now the delay here it is 4 seconds for each. So when it's on retry, you know this already, isn't it? Okay, yeah. So we're going to add a retry. We have a retry strategy stated down here. Then our circuit breaker, we also have the circuit strategy stated. And we can go ahead, grab this, and pass it on. We are done. All that you need to do here is to make a request with this. So you know, in the V7, that's the version 7 of the Poly, when you have 2 or more strategy like this, or the 2 policies, we call it policies in there. When you have 2 policies, you need to use wrapper. You need to wrap these policies. But here you can see that we are not wrapping the policies. What we can do here is we have an extension that we keep adding. So we can add a lot in here with the same return type. We can group them and now start using. And that's very usefulness, or the very nice and lovely thing about the poly.core. Even the version of what, 8.4, version 8. Good, so I'll entreat you to use this all the time. Okay? Yes, and I believe you love it. Okay. So now let's see, we're going to make a call to this. And now this is going to return HTTP response no. So let's pass in the token in here. Since you want to return a list, you don't want to be working again, let's pass in the API 2. So we can have access to the one which returns the list of weather forecast. Save this, run this, and now let's check it out. Oh, that's great, fantabulous. We have it ready set. Now let me open this our console. This is our endpoint circuit breaker. Now let's have a look. So I'm going to click on try this out. Now the first trial is not going to hit, so we're going to have on try first, second, third, then circuit breaker will step in. So this is implementing a retry. This is the first attempt. No, it couldn't work sending. Still not working. Let's see the response. Yes, so we have a second attempt. So this couldn't succeed. Second attempt in here. Now let's wait. Oh, this also. Let's see it's going to succeed. Now it is sending. So it couldn't succeed. Now soon I get to the third one. So there is a 1, 2, there's a third one. You can see that circuit is open. And now when circuit is open for 30 seconds, you can see all subsequent requests are not hitting. They are the back of the connection. You can see on retry attempt 2, 3, they are not executing because you don't see any start processing, right? We have 2, 3, they are the back in here waiting patiently. Good. So let's see, we have a 2, 3. Now when we check, let's see, because we have 4. Now we made it up to 6. So it's going to execute to 2, 3, 4, 5, 6. Maybe 5. because it is starting from 0. So 1, 2, 3, 4, 5. We made answer 8. So we have answer 3 is going to be 7th one. Let's wait and check it out. Okay, so when you go to the 4th one, circuit is half open. Now next call is a trial. So you can see that it opened for 30 seconds. It executed the 5th one. Okay, and now still it couldn't. So it has to still close it. Now you can see here it did not try for 3. It tried only 1, and as I couldn't succeed, it closed it again. So now it is closed. This is the 5th one for 30 seconds. Now it's still going to execute from the. We made this 8, right? So it has 2 extra left. Now when it gets to 30 seconds, it's also going to try another one again. In case it couldn't, it will keep what? Closing. So let's see. I'm going to try it. So in the execution process. So if we check this, we specified how many times. Okay, this is our retry. It is 8, right? So we need to have 0 to 7 to grab that. So you have the 5th one. So let's still wait while it's making the call to get the 6th and then the 7th one. Alright, so you can see that it also lasted for 30 seconds. It tried the 5th one, half openness, so it's a trial. And now still it couldn't, so also 30 seconds. The 6th one is also there. It's going to wait for 30 seconds, make another retry, and now check it out. So you can see that's how it is doing. So it checks out from that the first one on trial. It checks if the call we made. If not, then it's going to close that again. Okay, it's going to open the circuit again. In this case, all endpoints coming in. This is only from one client. The next client also going to execute, also going to be hit, and I don't have access to the resource that he or she needs. Okay, while this on the trial purpose, let's see, let's run the API 2. Now this on try on the 6th one. Circuit is closed, circuit is open. Now let's see, circuit to be closed will be open. It will be closed for trial purpose. Okay, now let's see if it will get the content that we want. Circuit, now we have the endpoint here ready, 7001. Now let's wait for this type. Circuit is half open again, and now when it's half open, a call will be made again. And now by then the server is alive, so we have to get a successful response. Let's have a look. So when you check this, you can see they're still processing, isn't it? Let me close all these because these are all the old ones. So it's still processing. Now let's wait and see the 7th one. Yes, you can see circuit is half open. Next one is a trial. And now when you get it, because now circuit is open for 30 seconds again. Let's see, maybe it could not get what. Okay, so it's still requesting. Let's see. So maybe this will take our time. So maybe we can just reduce the size or the time specified down here. And now let's say this attempt is 8. Now in that you wait for maybe 2 seconds each. Aside from that, when we go to our pipeline that we created for our the second that you break for, maybe let's make it as 5 seconds. Okay. Now sample duration, let's make it as 10 seconds. Now let's try this again. So let's execute this circuit breaker. Try this. Execute this. Okay, so let's wait and see. So when we check the console in here, it is still attempting this, and it tells you that although we have this running, but it is not getting it. 7001, it is not getting that, and this is it's not getting this. Maybe let's check it up again and see it well. So from the solution API 2, when you go to the app setting, not the app setting, dependencies or properties line settings, we have the endpoint here as HTTPS as 7001. Great. Now when you go to the weather forecast 2, we are making a call to API 2, and that is 7001/weather forecast. Okay, this is what we have. Do you have this side? Do you have API to this? From API 2, you know this from the API 2, and from weather forecast, we have, okay, there's no API at all. We have only this weather forecast. So maybe I can grab this again. And now from our controller, and there's weather forecast as well. So making a call to 7025, and you can see this is wrong. So making a call to this, and this supports 7001. So 7001, we have this as a connect to API 2, and that is what we are using down here. So yes, so this is going to work. Now let's give it a try. So let's try this. Now the service is off. Okay, so you're going to have a retry count. All right, so I think the service is already on. So you can see we have the response here. We're going to close API 2. This is API 1, and this is API 2. So let's close this. Now let's make a request again. Now let's check our console. That's we're going to have our retry. Yes, have our retry, and that's great. So let's wait. Now this is on the first attempt. When it gets to the second one, circuit is going to get closed. So let's see, attempt 1. Attempt 2 is about to execute. Yes, done. Attempt 3, now circuit should open. That's great. So you can see that from the circuit is now open. And attempt 2, attempt 3 is off. We see, as you can see from here, they are not executing. Now we see this half open. It's going to check, and it's still going to be off because the service is not active. Yeah, it's still closed. Now let's make the service active. So from the API 2, I'm going to right click on this, go to debug, start with the debugging. Now let's see. Let's wait for a section which is on trial. So we have a half open. It's a trial, and it couldn't. Now from the attempt at 4. Let's see, this new call can be made. Good. So you can see from here, there's a trial. It's not to make the call. There's a starting, and there's a sending. Now there's a receiving. So it has received the response. And as soon as it made that trial, it now make a call as all circuit is closed. Circuit is what? Closed. So all calls can be made through. And now when we check the response, you can see now we are going to have the response in here. Yeah, so that's what we are seeing here. So all calls from the number of throughput that is specified, it's going to make an attempt. In case it fails or all failed, the circuit is going to be closed, no open. When it's open, no call be made available. Now for 30 timeout from the time that you specified, it's going to make a trial. In case it works, then it's going to close the circuit for all calls to pass through. Good. So now that we have this also implemented, what is the next one to talk about? So what is hedging? That is the next thing that we're going to talk about. Now, hedging is also one of the strategies or the resilience strategies of poly.core. Now, what's actually the function of hedging? Hedging actually helps you to handle scenarios where external services such as APIs might fail temporarily due to network issues, high load, or other transient fault. So in this case, hedging strategy involves executing multiple parallel requests to the same service, usually an external API as we're doing in here, and then choosing the fastest or the most successful response. So let's say we're going to specify if you want to execute 3 responses, we're going to make 3 requests. Now the 3 requests that you're going to make is going to choose the fastest response in our display. So here, the motive here it is to check if the service might fail, then make a multiple request. And maybe by the multiple requests that's going to make, at least one will pass through. In case all pass through, then check the fastest response and I'll return. So that's the hedging. Let's see how to introduce or implement this hedging strategy. As usual, let me grab this. And now let me just do what you've done. Okay, that's what we've done. And I'm going to say this is hedging. Okay, now let me open this. And they all have the same return type, right? Okay, so the next thing we're going to do here is we need to implement our strategy first. So let's first create a hedging strategy. Now, since we're going to check, this response is going to come from an HTTP response, because from the hedging, we want to check a specific status, and I'll make a multiple calls again. So in that, we want to handle an exception whereby the result here it is an internal server error. Okay, so here we are also making an explicit exception that we want to call multiple times. I hope this is clear. Good. So now let's see. Now we're going to create our hedging. So let's say this is var. This is hedging strategy. That's equal to new hedging strategy option. And in that, we need HTTP response message. Now, within our response message, we can now specify the following properties in there. So, it should handle all response HTTP response message found in any exception, which has a result of what the status code is for internal server error, that is 500. Now the maximum head that's supposed to make a call to is for 3. Delay for making each call it is 1 second. And now here we are having this action generator, that is in case it's about to, then preparing to execute hedge action. When it is on hedging, when it's executing, then we can specify the attempt number, because here we're making 3 attempts. So we can get attempt 1, attempt 2, and attempt 3. Good. Let's implement this in our pipeline. So here, all that we need to do is to create a pipeline and now use the hedging that we created. So hedging strategy, we grab these and we can pass it on in here. Let's remove this. Then we can see this is hedging pipeline. Then let's use this hedging down here, because here we are returning HTTP response message. Okay. And now with this, you see we execute the token. So here we're executing it straight ahead. Or, this message is returning HTTP response, right? This endpoint. Where is it? We created 2 endpoints which are executing, yes. So connect to API 1 is executing what? HTTP response message. So we can call that in there, or we can execute it straight ahead as well. So maybe instead of this, we can also call this in here, like this, and it's still going to work. Or you can specify it straight ahead in there. Now we're checking if data is equal to success, or if the status code is success, then you want to read from the response that has been received, and I return the list. In case it isn't, then you want to return the status code of that. Good. Now let's see. So let's run this and check this out. Alright, so it is ready. Now we're going to execute a hedging, and that is this one. So hedging, let's execute that. Before that, let's make our this visible. So click on, try this out, and now execute. Now our service is off. So let's see, you can see on hedging is attempting. So preparing to execute hedging action. Then on hedging, attempt 0, attempt 1, attempt 2. And so it couldn't retrieve the message. Okay, so it means the server is off. Now have a look from the response that is getting to us. So when you check it here, you can see that we have this response. No connection could be made because the target machine refused it. And that's what we have in here. Now we are returning the status code in case you couldn't. So watch here. From the response that we have in here, it is returning the status code of 500. Now there's the status code that's going to return, as you can see from here. And now there's a custom message from our exception handler. And now there's the actual message from it. So you can see that it made 3 attempts. Then it will choose one in case it's working. Okay, but it's not working. So this is what you're going to do. We are going to, let me on the API to the server or the service. There's a service, not a server. Although we see it here, but it's a service outside that we don't know. We are making a call up to. All that you know is the URL, right? The address. Now let's try this again. Let's make sure both are up and running. So from the face here, let's execute once again. And now watch here. You can see that here it's making a request. Now you can see we have sending, first request. We have sending again. So you have it from here. Start processing. We have sending. Then we have receiving. Now let's see. So we have the response from this. Okay. So we have that there's a response that we have. So this is a receive response that we are having down here. Okay. So in case it could not connect to the service, it's going to retry and get us the fastest. So in case it does too, then it's going to give us what we need as well. Okay, so that's the hedging, and we can use that as well. All right, now let's talk about the last one for this video or for the day. And that is a rate limiter. Now, rate limiter, it is a technique that is used to restrict the number of requests made to an API or service within a specific time window. And it prevents an excessive traffic, whereby protecting the server and ensure fair usage among clients. So, now with this, you can specify the number of requests that you want the server to handle at a time. And aside from that, in case you have that request and there's a new request, it's going to queue that or reject it. So in this case, you can preserve the server from overloading or from crashing. Good. Now that we have this, we are not going to use the poly. Poly also has its way of implementing this, but there's a default package in Microsoft, and that's what we're going to be using in here. Okay. So we're going to use a default rate limiter from Microsoft, and this I think is available from version 7. Yes, from version 7 and number. So talking about version 7, version 8, and the feature versions. Now this is default and they can use that in. So there's no need for you to use any external package again like the poly or the poly.core. Now let's see. So this, we're going to implement this in the service. So let's say this is the service, the API 2. Now in that, we go to our program.cs file, and that is where we are going to implement this this rate limiter in there. There are 4 types of rate limiter that we can use. We have the bucket token, or that's the token bucket limiter. We have the concurrent limiter. We have fixed window limiter. We have sliding window limiter. Okay, we're not going to talk about any of all of these. We talk about the essential and the current one, or the one that you can use, the flexible one. Okay, and that is the token, the bucket token, or the token bucket, the token bucket limiter. Now, what actually does this limiter do? This here, the name implies, the name here is what? The bucket of token. So if any request coming in, it goes to the bucket and now assign or pick a token from the bucket. So all requests coming in are going to have a token. Okay. Now, when the token in the bucket gets finished, if any request comes in and decides to go in for a token, by then there won't be any token. So that request is overloaded. It's overload. Then it has to move it to the queue. In case you want to specify a queue, it has to move it. But in case you don't want to specify a queue, then it has to reject it until the tokens are, until the new request, until the all requests which have token are being processed. And now we can also specify the replenish time. Let's say the time that you want to refill the bucket with another token. So every 30 minutes, when the token gets exhausted, I want to use 30 minutes to fill it again. So every 30 minutes, the bucket is going to be full. Every 30 minutes, it's going to be full. So within that 30 minutes or 30 seconds, all requests coming in, if they are 30, it's going to have token and I get executed. In case they are less, there also still be an extra token. And every 30 minutes, there's also going to be another token which is going to be added to what we have in the bucket already. So at the time, there will be a full bucket of token, unless the request comes in subsequently so that the token gets exhausted in the bucket. That is where they have to wait for 30 seconds for another token to be added before these processes or these requests can be processed. Okay, so in order to do that, we have to add the token or the bucket service. And I think that's what we are doing. So build out the services.add rate limiter. This is the default one. And now here we are adding the token bucket limiter. So we give it a name that we're going to be using or retrieving to apply to the controller or any action method in the controller. Then we're going to have it as auto replenishment time. So time that you want is to get the token, you want the token to get filled in the bucket. Set it auto through yes. Now what is the token limit? So anytime pass it on only 3 tokens. So it means you're going to accept only 3 requests at a time. Now what is the token per period? So what is the number of tokens that you want to get filled in the bucket per period? It is 3. The bucket is taking 3, and now per every period, I want us to add 3. What is the queue limit? So here I'm queuing 2. Okay, and now from that queue, I want to, if I'm processing the queue, I want to start from the oldest, the first queue that came, and the latest queue will be the last one when processing. So first come, first serve. And now what is the replenishment period? So how many or how much time do you want to refill the token, the bucket with token? That is a limit of 3. That is every 5 seconds. Okay, so now once you have this, let's see. Now this is when reject. Maybe you can use console.log to log this. And now here it's having an this is an event that can get called whenever a token is rejected. Token can be rejected when the queue limit is 0 or the token this limit exceeds. When the queue limit exceeds 2, then all requests, subsequent requests are going to be rejected. And in this case, this can get called. Okay? When token is rejected, this status code is going to be released. That is 429, too many requests. Alright, so we're going to set here to 2. And now when we are done, when we try this and it works, we're going to also set here to 0. It means we are not queuing any requests. Then let's see that this status is going to get called. Okay, so once you have this, the next thing we're going to do here is we're going to be using this in the controller to protect the specific endpoint. So from the only controller that we have this bucket token. So we can go in there and now implement this. So let's go to, let me copy this. Let's go to our weather forecast from this weather forecast controller. And now in here, we want to enable rate limiting. So enable rate limiting. Now in that, specify the limiting that you created. That's the bucket token limiting or the limiter. Good. So once that we have this, let's see. So this is going to allow 3 requests at a time. And you're going to queue 3. Good. Now let's go in there and make requests to this. So how do you make requests to this? You're going to make a call to this. Okay, so let's go to the endpoint. And now from here, let's create another endpoint to make request. So maybe I can just grab this from here and now down there, let me minimize this, also this and that. Okay, and now in here I'm going to say this is rate limiting. Now let me also have it same. Then I'm going to say this is var. Okay, so let's say this is results is equal to, you can have an await. Then let's call this. So connect to API 1, and you can check if results dot success status code. Then we want to return. Okay, and now here we're going to have await results dot content dot read from JSON async, and that we can specify the enumerable of this weather forecast. So else, what are we doing? We want to return maybe bad request. Okay, so else you want to return this bad request. Okay, or we can return the status code from this. As for this, you can manage it to suit what you want. But what you want to focus here is that all these requests are not going to be executed when it exceeds 3. For us to get the request, or that's a status code, that's a rejected status code, or too many requests, as a 429, let's return maybe status code. And now this status code, you can pass in this result dot status code. And now since this, we need to typecast this as what? Integer. Okay, so now let's run this and check this out. So let's make sure we have API 1 and API 2 both running. So there's an API 1, as you can see from the title. There's an API 2. Okay, now from API 2, let's try and see if you're going to return a list of weather forecast. Great, you have it. Let's go to API 1. And now from the last one, rate limiting, let's execute this and check it out. So from here, you can see we're executing it, and now we have the content in here, right? Let me minimize this more. Okay, now I'm executing this. So I'm going to execute this simultaneously. Now we need to execute it more than 3. So check it out. So execute this 3. Now you see we have this. You see? So when it exceeds 3, now wait. First one, you get executed. 2 executed. 3 get. Now let's see it. Now this is what we're going to do. It's going to queue that. I want us to increase the time so we can see this well. So let's go to our program. Let's set this, the queue limit here, to 0. Now let's save this. Let's run the API 2. And now we are using this in the bucket tokens here. Inside this weather forecast, that's the API 2 weather forecast, and that's the rate limiting that we are using. Okay. Now let's see. So it's ready. Now let's execute this. So we need 3 times. So you can see. So when you execute this simultaneously, it gets stuck. So I believe after the request, it should have, because since we have the queue limit of 0, it means there shouldn't be any queue. And if there shouldn't be any queue, then it has to reject it. And we have to get a status code, but we are not having that. Do you see this? Maybe there's something wrong here. Yes. It's time for us to debug our code and check it out. Good, so let's see from this. After we are done with this, we add a rate limiter. Oh, okay. We did not use that. So app.use rate limiter. That's great. This is what we missed. So we are not using it. Now let's run this again. And I'll run our API 2. Okay, so we're going to run our API 2. Now, since you're having the rate limiter to, or the queue limit to 0, it means you're not queuing anything. So aside from if the server or if the service takes the first 3 response or the first 3 requests, the subsequent ones is going to discard that until this is the time period that we specified. So let's say this time period, we want to do this as maybe 10 seconds, okay? So that you can just put in a new token for a new request. Okay, let's do this again. Alright, so let's give it a try. Now API 2, API 2. Let's see our API 1. Now rate limiter, so it's going to accept 3. So let's say you want to click on this one by one for some time, and you just press it again. This is not going to work. But when you click on this, when you make a request simultaneously, that is where this gets executed. So this is the first one. The second one, you wait for some time. Then we can now click on it again. Third one. Now let's see the fourth one, and it's still going to work. Click on it, and you can see now we have it. This is the fourth one. Now let's issue request simultaneously 3 times and check it out. So 1, 2, 3. Now let's check it out. We have the response in here. Okay, yes. So you can see that since you're not having any queue, it took our first 3 requests, and after that it rejected the subsequent ones. So you can see I have 429, and this trace ID with the status of 429, which tells you that too many requests. That is the status, so that's the meaning of that. Now when you wait for some time, it's going to replenish the bucket with full of tokens again, and the subsequent requests also go again, because now we have it. So if let's go to inspect element here, and now from our network tab, if I make a request, because we have it in here, and this is going, status code is for 200. Now check it out. Now it won't go. So let's see. You can see the rest are not going for some time, and the other one will go. So once I made this subsequent request, you can see that some of them are rejected, others are passing through when the time is up. And when the token or bucket are full of 4 tokens again, then the next is going to get executed. You see? Yeah, so this time the server can now have some time to breathe, can have some time to process a new request coming in, and it can close all those popping inside the room for processing. And when at its own time, you can now go ahead and now make a request to them or serve their request that they want. Alright, so in this video, we've covered, I think, 6 techniques that you can use to implement or to boost your API by creating resilient and now robust. We've seen how to apply the retry technique, how to apply timeout technique, how to apply the fallback technique, how to apply a circuit breaker, and lastly, how to apply the rate limiter technique. Yeah, this concludes the video. I think we spent about more than an hour now, so I'm going to end here. I believe you've learned something, and you can now boost yourself and now implement a real API project which is strong enough to resist to any issue that may pop up against it, okay, by implementing any of this. It is not mandatory to implement all of this in one API project. Based on what you need, you just implement in there, and now off you go your way. While the project scales up, you can actually add more to it. That is it for the video. Thank you so much for watching. I hope you enjoyed it, and hopefully I'm going to catch up again. Till then, take care.